Alright, this is Lab 65, Chemical Batteries. Today, your challenge question is, what combination of metals makes the best battery to power a small motor? As you can see, you have several different metal combinations that you can predict which combination is going to make the motor run the fastest to the slowest. Okay. If you take a look at the first data table, how we're going to test this is we're going to take a combination, observe if there's any chemical change when you place the metal into the electrolyte liquid. A chemical change is like temperature change, fizzing, bubbling, and so forth. With the motor speed, you're going to explain what type of speed it is. It could be very fast to moderate speed to slow or very slow or not even spinning. And then as soon as you get the motor speed for all of the combinations, you want to rank it from 1 to 6, 1 being the fastest combination to 6 being the slowest. Okay. If you take a look at some of the materials that we have, this is your battery chamber. What you're going to do is you're going to mix hydrogen peroxide, 5 packages of salt, and 25 milliliters of water into the cup, and make sure it's stirred in. This makes electrolyte liquid, which means the material that makes the liquid electrically conductive. Okay. So I'm going to pour that into our chamber here. All right, so that's the electrolyte liquid. Then, if you notice over here, we have 2 clamps, one's positive and one's negative, and a small motor. All right, you're going to clamp the positive and negative clamps to these little brackets. All right, make sure that you don't break those. And then at the top, you have a little flag, and you're going to see this spinning. Okay. All right, for the first combination, we're going to test magnesium and copper. All right, if you come over here, these are our 4 metals. All right, this is magnesium, copper, this is iron, and this is zinc. So we're going to take magnesium and copper. All right, we're going to place them onto our clamps. Okay, and then what you're going to do is place them into the outside parts of the chamber. The first thing you want to observe is if there's any chemical change. So if you place it in there, you can see some bubbling. So in your observation over here, you're going to write down bubbling. For the motor speed, you're going to see the motor running. As you can see, it's a very fast speed. All right, so you're going to put very fast under copper and magnesium. Okay. After each combination, you want to be sure to dry these off and scrub them with sandpaper. All right, the next combination is magnesium and iron. Okay, so we're going to take magnesium and iron. Again, you want to observe any chemical change when I place them into the electrolytes. All right, so there's some bubbles. So write down bubbles, and then you want to observe the motor. All right, as you can see, it's still fast, but the other one was faster, so you can record fast for the motor speed for the second one. All right, the next one is zinc and copper. So here's zinc and copper. All right, so I'm going to place them in here again. This one you can kind of see some bubbles. So you could write bubbling again. And then sometimes if it doesn't go right away, you have to flick it a little bit. As you can see, it's probably a medium speed. So for here you could put moderate to medium speed for zinc and copper. All right, the next one is magnesium and zinc. Okay, so zinc is there already, and now magnesium. You can see maybe a little bit foggy there. All right, so you could put fog in the observation, and then we can observe the motor. As you can see, it's a little bit slower. So you're gonna put slow for magnesium and zinc, slow for the motor speed. Okay. The next one is zinc and iron. Okay, so I'm just gonna switch this one out for the iron. The difference between iron and zinc is a little more flexible than this one, okay? All right, so let's place those in there. Oh, this one you saw lots of bubbles when I placed it in there. Yeah, see? So bubbling again for your observation. Let's check the motor out. As you can see, it's barely moving, right? It's super slow. So you could say slower for iron and zinc. Okay, the last one is copper and iron. Okay, so iron's still there, and then copper and iron. We're gonna place those in there. You could say bubbling. And if you check out the motor, it's not spinning at all, so no spin on the motor speed, no spin. Okay, so now looking at your motor speeds, you want to rank them from 1 to 6, 1 being the fastest, 6 the slowest. So if you remember, the first one was the fastest, and then it goes in order, 2, 3, 4, 5, and this one's the slowest at 6 because there was no speed. Okay. If you take a look at the chamber one more time, notice that this is a circuit, because you have your electrolyte conductor, you have 2 metals, and it's going through the circuit all the way to the motor in order for that to spin. So that's how we created the battery, okay? So that's part A. Now when we take a look at part C, all right, what you're going to do is you're going to now investigate what happens when you move the metals closer together. So you're going to use 2 different metals that turned it slowly. So we're going to pick a combination that was pretty slow. We're going to place them in the slots at opposite ends in the chamber, and then we're going to move one strip from slot to slot so it gets closer to the other strip. We're going to see what happens to the motor speed and record. So if you take a look at our next data table, okay, we're going to use magnesium and zinc for our combination. So let's set that up first. So magnesium, all right, so this is magnesium and this is zinc, okay? So as you can see, I'm going to test slots 1 and 6, so they're the farthest apart, okay? So I'm going to place that in there. All right, they're the farthest apart. And you can see it's slow, right? So for our observation, it was bubbling again. All right, and then for the motor speed, I'm gonna put slow, because this was one of our slow combinations, okay? Now, I'm gonna see if I move them from chambers 2 and 5 to see if there's a difference. So I'm moving these over, so they're a little bit closer now. The metals are closer now at 2 and 5. And then, as you can see, our motor is speeding up, so it's a little bit faster. So you could put fast for the next one. Now I'm going to move them to the closest chambers 3 and 4. So now they're very close together, chamber 3 and 4. As you can see, the motor is now faster, so you can put faster for the last observation. All right, step 11. Now we're going to investigate what happens to the direction of the shaft, which is the little flag on the motor, when you reverse the connection. So we're going to use zinc and copper, and we're going to record what happens. All right, so for my next table, it's zinc and copper. So zinc and copper. Okay, so as you can see, my zinc's on my red and the copper's on the black. All right, so I'm going to place them in my chamber. And you're going to see that it's going counterclockwise. So do you see that, how it's going counterclockwise? Well, now I'm going to reverse the red and the black clips. So I'm going to put the black one on zinc, the red one on copper, and I'm going to see if the direction changes. So as you can see now, it's turning clockwise. So it reversed direction. So in your motor direction, you could say it reversed direction from counterclockwise to clockwise because we changed the, we reversed the connection of the clips. Okay, and now step 12. The last investigation is we're gonna see what happens to the motor as we gradually remove the strips out of the electrolyte liquid. So we're going to use a combination that caused the motor to spin rapidly and record our observations. So I remember that copper and magnesium was a combination that was the fastest. So I'm going to use that combination. So you could put copper and magnesium in the step 12 zeta table. And what I'm going to do next is I'm going to put them fully into the water, and then at halfway out of the water, or the electrolyte liquid, I'm going to observe the motor speed. All right, so as you can see, it's super, super fast. Now I'm going to take this out of the water halfway. As you can see, it slowed down halfway, and then as I pull them out even further, so they're about to come out, it's super slow. Okay. So halfway out, you could say it slowed down the motor speed, and then 3/4 out of the way out, when it was almost out of the liquid, it slowed down even more. All right, so now you're going to do analysis 1 through 5, and that is lab 65.